Geometry, today we begin the wonderful wide world of proofs. And we're going to start with something that you understand, which is equations. Where we're starting our proofs with algebra, because you know how to solve an equation. Now we're just going to set it up in a formal proof and use reasons to defend each step. Okay? And there are 1, 2, 3, 4, 5, 6 properties that you've been using for a long time. You just didn't know what they were actually called. Okay? So these are the reasons you're going to have in your proof. That's why they're key points. They can go in a help sheet. Okay? You should be continually building your help sheets from unit to unit with all these different properties and postulates and theorems. I recommend if you've not already started like a Google Doc that you just continually add to and print out for every single test, highly recommend that you start that because you're going to be needing these things in every unit that we do moving forward. If you're constantly writing it out over and over on paper, then it gets to be a little bit tedious. So, the addition property. We'll be using some conditional statements here. Okay, if A equals B, then A plus C equals B plus C. That is the addition property. If A equals B, then A plus C equals B plus C. Someone kind of dissect that one for us. What does it all mean? It's a lot of letters and such. Luca.
C will always bring it together.
I see. Hugo.
Thank you. If two things are equal, then if you add the same number to them, they'll still be equal.
Right. If two values are the same, adding the same value to each of them will keep them the same. Okay? If A is already the same as B and you add the same value to both of them, okay, it's still going to be the same value. What do you suppose the subtraction property is? I'll give you a hint. It starts with if A equals B, then A minus C equals B minus C, right? If A is the same as B, you can subtract the same value from each of them and it'll still be the same value.
Is that the same for the multiplication?
Yes.
You guessed it. The multiplication property, if A equals B, then A times C will equal B times C. If you have two values that are the same and you multiply both of them by the same thing, they're still going to be the same. All right.
When?
Huh?
When, roughly should our next test be?
Before Thanksgiving break, probably next week, but it'll be a try-2 grade. So all of the POs that you have currently assigned to you on Blackboard, none of that will change. You're not going to get any more between now and the end of the try.
And how many days are we on the try?
How many what?
School days.
School days, not including today, 8.
Oh.
Boo.
Yeah,
What day do you stay after?
Mondays and Thursdays. So I'll be here on Thursday.
On the Wednesday, how do we sign up? Yeah, how do you sign up?
So on the weekly update that gets emailed to your parents, there's a link to a Google form that you can sign up on. If you don't sign up, you can call your parents. Basically, just the office needs to know who's here and where people are. So if you don't sign up and you want to stay after it, you just have to call home from the office after school so that they know where you are. And we have parent permission for you to be here. That's what it boils down to. Yes?
So you're going to be here Thursday and then next Monday?
And Thursday, yes.
And Thursday, and then do we have Friday as a retake?
Most likely. I'm not going to make any promises, but most likely. Yes?
On the Wednesday that we have off on Thanksgiving break, do an entrance exam.
Oh, for what school?
TG.
Man, that's just brutal. That's just brutal. Well, on Thursday, you thankful it's over. So there you go. Division property. If
I am master water.
A equals B, then A divided by C is equal to B divided by C.
Unless C is 0.
If C is unequal to 0. This one's got that other condition because that whole divide by 0 thing can't do it But if A equals B, then A divided by C will equal B divided by C. Okay? The substitution property, I want you to star this one. This is going to be used in proofs a lot. Okay? A lot. And what this says, I should have put 2 lines for this one. But if A equals B, then A can be substituted for B in an expression or equation. If A is B, then A can be substituted for B in an expression or equation. In PO16, we'll use substitution a lot. But
Isn't this like oxygen?
no.
What is substitution? Do we?
You've done substitution before, right? Oxynoid is the elimination method, where you cancel them out. But the first method that we learned, that was substitution, yes. Yep, excellent, yeah, very, very good. Yeah, so you've used it before to solve systems.
Because then we figured out like what one thing was equal to, and we put it into the other one.
You substituted it, exactly, exactly. Okay? Okay, and then the distributive property, you've done this before. This basically says that A times the sum of B and C is equal to A times B plus A times C. You can distribute that coefficient into the parentheses, multiply each of them. You've been using that one since, oh goodness, all the way back in pre-algebra.
5th grade.
PO,
Fifth?
fifth grade
That's
you first
sixth,
learned it?
sixth,
Sixth grade? Yeah. Okay? All right, questions on any of those properties? None of them are new, right? We used all of them at some point before, but now we're actually naming them. Okay? What?
Well, we have
Yeah, I don't know yet.
Wait. I was not talking. You were talking.
Talking to you. I saw you turn around. Okay. Good? Good? Okay. So here we go. We're going to practice writing proofs with solving equations because you already kind of have an idea of how this is supposed to look. We're just going to do it as a formal proof. Okay? So it says solve each equation, write a reason for each step, use the backside if you need more space. Hopefully we don't. There's a lot of space here. But to do a formal geometric proof, you need to make a statement and then have a reason. Right? So you are stating something and then giving a reason to support it. Okay? So what type of reasoning are we using when writing a proof? Inductive or deductive? Everybody. Deductive. Right? Because we have a statement and then we back it up with something. Okay? And in every single proof you will ever write, your first statement and reason is always what you know, what's given to you. Okay? What you already know. And what we know is that 4 plus 8x is equal to 10x minus 10. That's what we know. Okay? That's what we know. 4 plus 8x is equal to 10x minus 10. And that's a given. Now, if you were solving this in algebra, back in PO7 or back in PO62 in pre-algebra or whatever, raise your hand, what would you do first? And there's a couple different options here. So it's not one specific, but what would you do first, James?
Move the 8x over
And how would you do that?
by subtracting it.
Okay? So you were taught to use opposite operations. Right? Algebraically, if you were showing your work, you would use opposite operations by subtracting 8x and moving it over. In geometry, you don't have to show that work. Okay? If we do move the 8x over, our second statement would be 4 equals 2x minus 10. And that 2x came from subtracting the 8x from both sides, right? Okay? Now what did you do?
simplify.
What did you do? What property from up above, what property from up above was used to get to that second step? And I left a little space because I'm going to show some extra work here, just because it's your first one, but what was used? Emmett? That's what we did, but up above, all those properties that we wrote down, which one did we use that allows us to, because what James did was he subtracted the same thing from both sides, right? We don't write the minus 8x because this is geometry, not algebra. But what property from up above, Hugo?
Subtraction.
The subtraction property. The subtraction property. You can defend that 4 equals 2x minus 10 because of the subtraction property. If you subtract the same thing from both sides, it's still going to be the same. It'll have the same value. That's what the subtraction property says. Okay? Now, algebraically, what would you do?
I moved the 10.
You'd move the 10 over. How?
By just like adding it to both.
Adding it. You don't have to write this part. This is the, the algebraic work. In geometry, we would go straight to step 3, and we'd say 14 equals 2x. And we defend this by which property?
Addition.
The addition property. Because what did we do? We added the same thing to both sides. Are you kind of seeing how this is playing out here? Okay, you make a statement, you defend it. You make a statement, you defend it. Okay?
Until we solve it?
Well, we're not done yet,
Well,
but
yeah, but like
yeah.
that's what we're getting to.
That's what we're, yes. Okay? When we start proofs in 16, like geometric proofs, this is the format that you're going to be writing them in. Okay, so we're practicing the format with something we all already know. And what would step 4 be?
7 equals x.
Evan?
Division.
Okay, we would divide both sides by 2. You don't have to write that because that's the algebraic thing. You would just write 7 equals x. Who said 8? Okay. And what property can we use to defend this? Division property.
Isn't this kind of like just busy work? Writing out what you're doing.
It's practice.
So, in algebra, Evelyn, I had you show the red part because that's the algebraic work that goes into solving this. Geometry, the geometric work, so to speak, showing your work is what's in green here. So it's not busy work in the sense that, like, if you were explaining to someone how to solve this equation, algebraically, you'd explain it with opposite operations and go through what we did here in red. Geometrically, truly mathematically, you'd explain it by going through what's here in green. Now, is green a lot more work than the algebraic? Yes, but if someone says, why can we do this? Why does this work? Mathematically, how does this make any sense? You would then have to go back to these properties to show them, hey, if you've got A equals B, two things that are the same, and you add the same value to each of them, it's still the same. Okay? And that's what's going on. You're showing your work geometrically. Basically. Busy work, far from it. Luca.
So it was like the reasoning, like of like making instructions? Is that
Kind
what
of.
it's kind of?
Sure. Evelyn.
Are we gonna have to write this all on the test?
Yes. There will only be 2 for CO15 on the test. Your 4 points. 1 point comes from the proof. 1 point comes from getting the correct answer. So if someone had said like x equals 8, something like that, right? Then that person wouldn't get that point for it. So 1 point's the proof, 1 point's the correct answer.
So we have to get at least 3 to pass.
Correct. Hugo.
Did somebody have to write proofs for the properties?
Yes.
Then how do you write the proofs if you?
That is, thankfully, that's been done for us. Like, your calculator can calculate sine, cosine, and tangent ratios and square roots and all that stuff for you. Someone had to program it how to do that. Thankfully, we don't need to know how, because someone did. But yeah, there are proofs for all the theorems and stuff like that. No. Bring your water bottle.
Forgot it.
Well, someday you won't. Okay, next one. Here we go. make your statement and reason chart. And generally you want to make your statement section a little bit bigger than your reason section. Because these equations, especially this one, can get kind of long. Okay?
I did like distributed property segments.
So, what do we know? We know that 7 minus 12 times n minus 4 is equal to negative 18n plus 37. That's what we know. That's what we've been given. And what's our first reason?
Given.
Given, every single time. It's what's given to us.
I got these on the math test.
Did you really? Fantastic. Well, now you know how to, did you answer them correctly?
I don't know.
Well, now you know how.
Yes.
Algebraically, what would you do first here?
Distribute.
Right. Okay. Algebraically, you would draw the lines, right? They're little. Woo! Look how fun this is in algebra. Okay. In geometry, we would go straight to step 2, which is 7 minus 12n plus 48 equals negative 18n plus 37. Right?
I miss algebra.
And you miss it. Well, and the property, what allows us to do this, is the distributive property. No, it's defending our reasons with geometric properties and stuff like that.
What does that even say?
Distributive property. Sorry, I read our rules. Distributive property. Yes.
Wait, so we're not allowed to show our work?
You can show your work if you want to, but in a formal proof, you don't have to show the work. You just go to the next statement, and then how'd you get there? Okay? What would come next? What would we do next here? Evan?
Can we do that and stuff?
We can do the end stuff.
Add 18n.
Okay, there are other options, and I kind of want to do something first just to shorten this up a little bit, so I don't have to squish it together so much. Ella?
Combine the like pair.
Right. So in algebra, we look at what can we combine, and we've got that positive 7 and that positive 48, which together give us 55.
Where'd you get 48?
The 48 came from the negative 12 times the negative 4. When you distribute into the parentheses, negative 12 times negative 4. Alright?
Wait, I have a quick question.
Yeah.
Can you use like the addition property like a couple times?
Yes, you can use the same property more than once. Yeah. Yep. So now, negative 12n, 7 and 48 give us 55. So we have negative 12n plus 55 equals negative 18n plus 37. And what allowed us to do that? This is not up in your properties from up above, but Ella said it perfectly. We simplified. That is actually a geometric property, or mathematical, I should say, property that allows you to combine that 7 and 48. Simplify, you could write combined like terms, okay? Those are both acceptable things. And now you've got options. What do you want to do next? Who wants to guide us? Aiden, take us to the next step. Step 4.
You can add the 12 times to the 18 now.
Okay, algebraically, we're adding 12n to both sides. Geometrically, we just write the next step, which is 55 equals negative 6n plus 37. And what property allowed us to do this?
Addition.
Addition property.
Are we still able to write like add 18?
Yes.
What I'm putting in red or what I'm...
What, like the red, because I feel like that makes it so you don't do as many mistakes.
So we're doing negative 6?
So you can write what's in red if you want to. You have to write what's in green on the test. But yes, the red is optional.
Do we have to, can we just write addition? Do we actually have to write addition properly?
Why did you ask
Yes.
that?
I will allow you to abbreviate property to be prop.
PR?
Don't push it.
It's not that hard to write like
Don't
four
push it.
letters.
Audrey, Questions? No? Okay. What will be next here? What would our next step be? In red
37
for the algebra people. Luca,
Addition property again, right?
to do what?
Wait, whoa, my bad. Sorry. Subtraction.
Subtraction. What are we subtracting?
37.
What?
37.
37? So in red, algebraically, we're subtracting 37 from both sides here. Okay? That means our next statement, 55 minus 37 is 18, equals negative 6n. Our reason for doing it? The subtraction property.
Subtraction problem.
Can I do PRO? Or PROP?
Don't push it.
I'll push it, Pete.
And finally, what would we do to solve, close your computer. What would we do to solve this, our final step? Divide by negative 6. And we get negative 3 equals n. And we did that because of the division property.
Can we just write S, P, D, P?
Don't push it.
It's not that hard.
Don't push it.
It's really not that hard, Evelyn. It's really not that hard.
Pro right, 24 dive, 3.
Alright, this isn't fun, but it's easy.
This is fun.
It's awesome.
Okay?
Pro left.
Questions on what you see? Yes, sir.
I did it differently, but I got the same answer.
Yeah, so like I
I
said,
added it to
once
it.
you
I need
do what you have to do first, Priya, Emily, which is to distribute first, you're kind of locked into that step. Once you get here, you can move ends around or constants around. Like there's a lot of different ways that you could go. Regardless, you'll get the same answer in the end. Okay. So when I read through your proofs on the test, I'm not going to be looking for one specific way to solve the equation. There are many avenues that you could take, but you do need to get the correct answer in the end. Yes, Evan.
Get water now.
Your assignment, hold on, just wait till I say it quick. Your assignment for tomorrow.
Pro C chop.
Oh, one question.
Questions and
We
math.
can do better than that. One question.
How about 0?
She'll only assigns homework because he doesn't want us to get the number game.
Right. Yes, I'm giving you an opportunity to play the number game here.
Yeah.
I would like you to do, oh man, the book gives you 9 equation proofs.
No.
9 of them.
2 of them, right?
I have 2.
I'm not taking them, I'm taking
He's joking.
Let's do,
Ask me after 3.
3.
on page 109. Does anyone still need these notes?
No.
We good? Okay.
Wait, page 109.
On page 109. Let's have you do number 8,
Okay.
11, and 14.
Oh, that's not that bad. That's not that bad.
In the spirit of Christmas.
Take down the hardest one.
Your proofs must have all the characteristics of what we just worked on. You need to have your statements and your reasons written out. If you want to write what's in red, you can, but you don't have to. But what's in green is required. That's how you do that.
Don't forget to like and subscribe.